So I'm going to try to implement what I draw on SkyDraw there. And obviously I have no idea if I'm gonna be able to implement what I'm thinking about, but yeah. Probably gonna try to implement the things separately if I can. So like just create different functions on both the model and the view, and then try to call them from the presenter to test. I'm probably gonna have to. I'm definitely gonna have to change, I think. Or maybe I think I'm going to do first just the same. I create another function there. I think I'm not gonna need this queue here, and I'm just gonna do it on the model. I'm gonna show the draw that I have there on SkyDraw with the layouts. Yeah, but I created this other function. I'm going to delete this because I got this from ChatGPT, I think. I'm gonna try to do it from scratch. So I'm gonna delete this stuff. I'm probably gonna copy the one that I have, the one on the view, the uncollapsed one. And then for the buffer search pattern, the most confusing part that I was thinking about just now is how to know the parent. For this part, I'm gonna have to think, I think, because here they're doing based on the change directory, I think, and they don't do anything on the recursion. So the recursion obviously is supposed to go in depth. So I guess it's just based on the logic of the get current directory and list dir begin. So that's probably how it works. Yeah, but then how do they add? They add as a parent for the current one. Yeah. So they create the moment they create a new one, they make the parent the current one. Yeah, that makes sense actually. It's probably gonna be similar. So I was thinking about, like, I was very confused. I'm still am very confused, so I don't think the way that I was thinking, I think the way that I was thinking makes a lot of sense. And there's probably a solution that is faster if you figure out how to implement this way. But it's going to take a lot of work to restructure everything. And in some ways, I think I might have to think about this still, based on the way that I think I'm gonna do now. But yeah, I decided to stop trying to do this way because it's kind of confusing. But the way that I was thinking about is that the directory is kind of like a box. So I have the width, which is the state you're capturing to the viewport is the uncollapsed state of the directory. So yeah, you have the width, which is gonna be how many files. It's basically breadth first search, how many files you have on each level, and then obviously the more the deeper you go into the tree, the more you get to the maximum width. And then you have the height, which is the depth, which is how many levels you have on the tree. And what changes when you're scrolling, for example, is going to be determined based on the uncollapsed nodes. And it's going to change, depending on the state of the uncollapsed nodes, the shape you're going to visualize as you're scrolling is going to be different, obviously, because of the depth. So I was trying to think about it in this way, like you have a two-dimensional view from top, and then you want to translate that into a tree state. So as you scroll up and down, you reconstruct the tree state based on what the viewport's seeing, which is a two-dimensional thing. But I think it's just too hard. But I do think that I was thinking about calculations here, so I wrote a bunch of stuff. I can get the height based on the because I was thinking about like one of the components. Maybe I wrote this somewhere. The fundamental things. One of the fundamental things is that you have to translate the two-dimensional viewport into a 3 data structure. So you're basically implementing a functor which changes data structure into another, which the results the 3 states. And that you're gonna do that based on the events. Then the other thing that is key is the navigation, which in Godot you use dir access to navigate through directions, through directories. So the navigation, I think, is the confusing part, because depending on the state of the uncollapsed nodes, you're gonna have to change the way you navigate. So I think like this is the challenge: is how do you figure out? So I was thinking about like maybe there are some tricks you can do with the, for example, you can get the width of the directory just from using dir access right away, and you don't need to iterate. Maybe I was thinking about that, and then you do some calculation like that to think about like the maximum width of the uncollapsed states, and then you get the height of the viewports, and then you get the amount of items, and then just by calculating alone, you would be able to create this functor that would translate the state of the viewport into the 3 states. And depending on how much cache you want, you would change. You would put heuristics that update the 3 state based on the movement of the scroll. So I think that's probably, it might be more efficient, but it's just a lot more complicated. So the way that I draw here, the way that I'm thinking about doing this now, is like the presenter is the thing that is going to be on the tree. So from the presenter, you call scan in the beginning. So when the presenter enters the tree, it calls scan, which is the function on the model that is going to update or get the state of the directory using the access. So eventually this is going to call scan your directory. Here I put that, I'm gonna do this later, I think, but I think I'm probably gonna try to copy this code from Ericto, or however you say this. It's from a YouTube channel. That is an implementation of an LRU cache for Elite Code Challenge. So I'm gonna try to, maybe I'll use this, I'm not really sure. But I might use, maybe not. But if I do use, I'm gonna copy this and then try to just change so that it works on Godot. But I do think that I'm going to have some form of cache on the model. So first, I have to check on the cache each time, but I'm going to explain this after, because I thought about this after I thought about the other steps. So one thing that was confusing me is the sorting, which I think I'm not going to do the way that they are doing, because I don't think it makes a lot of sense. So the way that they're doing here is you pass the root node for this function. Then this is going to be the root path, because you change for the root path before you call this function, you change the dir access to the root path. So this is going to be the root path in the beginning. Then they loop over, they create the iterator, the list, to iterate over the files, the direct children of the files or folders, which are direct children of the current directory. And then they put them on this two lists here. And then they use the sort custom here to sort the files based on this struct that they have here. So like this is a templated function that depending on what struct you put here, there's going to be a logic on the struct that determines how the list is going to be sorted. So this part here is the one that was confusing to me and didn't make a lot of sense, because the way that I'm thinking about doing now is after every time that I encounter either a file or a directory, I'm going to push them directly to the queue. So I'm going to move the queue to the model, and then I push them right away to the queue. And because I want to push them right away to the queue, then there's this problem of they're not going to be sorted. But then this is the way that I might be wrong, I might have to rethink about this, but this is the way that I'm thinking right now. I'm going to push everything to the queue according to a batch size that I'm going to put on the model, which is going to be like a member variable of the model, which is basically the width that the queue has to have until it emits a signal. So I push everything right away to the queue each time, and I don't sort anything. Then when it hits the limit, the batch size, which this is the part that is kind of confusing as well, because it's going to vary depending on the directory, obviously. So if you have a very short directory and you have 100 files or 100,000 folders for the batch limit, for example, then you would loop over everything and then it would continue. But if you have a very large directory, then it might hit the limit on the first level. So depending on where it hits the limits, and this is the part I'm going to have to do on the other algorithm, I'm gonna have to put probably inside of the first loop. I'm gonna do breadth first search because breadth first search you go by levels and not by depth. So levels first makes more sense because the levels are the things that are being shown in the current state in the beginning. So I'm gonna do a mix of levels, and then if you encounter a folder that is in collapse, which probably is gonna be inside of the first loop, then you start the folder right away. So either it's gonna be recursion or do something else. I think I'm gonna have to probably do recursion maybe. Or I can see if I can use, this part is the one that I'm gonna have to spend the most time thinking about because it's kind of annoying. It's just the nuances of the Godot functions that they have in the classes. I'm gonna have to think about what is the best way to use them to achieve this. Yeah, but basically I want to get the surface level of whatever was the previous state and then iterate over, and then each time I just push to the queue. Then if it hits the batch limit, the model emits a signal. Then after the model emits a signal, the presenter is going to listen to the signal, so it's going to have a callback function. After the signal is emitted, the presenter calls callback function, which pops node from queue, and calls view function to update the tree. So this part is also something that I'm not 100% sure. So like there should two different ways to do it. One is to take all the nodes of from the queue and put them on a vector or something like that, and then call a function from the view with the nodes, with those nodes. Or I can call the function from the view by passing the queue. But I do think that's probably better to loop over, even though it's gonna be like an additional loop, which is not very good. But the problem is if you send the queue, like you're gonna mess up like the purpose of each thing, because the queue, obviously the queue is gonna be updated constantly. So the way that I'm thinking about it is like, what happens if you pass the queue and then you're updating the front end, and then the model pushes stuff to the queue? It's not gonna be good. So I think that's probably better to separate. This part is still not 100% sure as well, like if I'm gonna have problems. So like I was thinking about, I'm gonna have to probably incorporate a mutex or something like that, because it's very likely that, or I have to find another like way to, this nuance I'm not 100% sure what I'm gonna do, because it's gonna depend on what actually happens when I run this. But I think probably I'm gonna have to implement a mutex or something that stops whenever the presenter is getting the items from the queue, then stops the model from pushing them. But then if that's the case, I have to see if it's gonna wait or not. So I have to remember, I'm probably gonna look into the string class. The string class, they use mutex. So I think I'm gonna try to do the same thing that they do there and see if it works. Okay, so after the presenter does this, then this is another part that is kind of confusing that I was thinking about. So the conclusion that I got is that it's probably better and easier, at least from the beginning, to just upload the state of the tree. And like the only difference is that I'm gonna be progressively building the tree on the front end, and I'm not gonna rebuild anymore. So I'm just gonna build one time, and then I'm gonna progressively send the nodes from the model using the queue to the view. And the bad thing about this obviously is that if you have a very large directory, then you're just gonna take a lot more memory, because once you load the full queue, the full tree, you have to have the entire thing. So obviously, in order to not do this, I think you can like delete nodes that are not visible, or you can put some limits of the amount of nodes you want to load beyond what is visible. But I do think that's probably is a lot easier to start or to implement this first because of the way that the tree works. So like the logic to show the elements, show or not, decide show or not show, are on the tree class. And I think that Godot by default is going to implement some sort, like it's kind of like lazy loading, where it doesn't render anything that's outside of the view. So it's just gonna hide from the viewport, which means that it's probably don't need to try to update every time. It would be a lot more confusing, like I said, as well. So the other nuance to this, which I'm probably going to try to implement later, is that as this initial load is happening, initial load of the directory, then if there is an event, like a throw or an uncollapse of the folder, then I'm going to do similar to what I think VS Code does, which is to send a signal to the... So first check, I'm probably gonna, this is another thing that I was thinking about. So I think like the easiest way is to keep a hash map of the path. So it should be probably gonna be a string and the tree item pointer. So every time I create a tree item, I create, which is not very good as well, because it takes more memory, but I think it's going to be a lot faster. So maybe what I can do is like, if I do think that it takes too much memory, at some point I can put a heuristic that deletes the everything from the hash map, or cleans up the hash map, or something like this. And yeah, just additional logic and steps, I think. But initially, I think that's probably a lot easier, because what I was thinking about is kind of annoying, is that if I'm gonna send node one by one to the tree, then the issue is that, like, how do I insert the node? And the way that they were doing before, this part I'm not 100% sure as well, if I'm going to keep, like, because they are using the model directory class, which is a class that they use inside of the editor file system, to call the functions from the model directory directly to create the tree items on the front end. So they're using the same class basically from the model in the view. This part I'm not 100% sure how I'm going to do. I was thinking about creating this other data structure here, but I don't know if it makes sense as well. Because I think it's going to be easier in the beginning if I just do the same node, because it is kind of like the same thing. I think that the advantage of having I think that's the main difference, is that because they were building everything in the beginning, it helps to have the classes, because the classes, you already have the children. So you can you can count the child of the tree, because it was built on the backend using the PEDIR, which is the name that they put on the view. I'm still doing this way because I copied from them on the update tree. But basically here on the recursion, you can call, like, this PEDIR here is the class that is built on the backend. So they build this class here, and then they use basically the same one to build the tree. And then you can because this one gets the subdirectory, it stores the subdirectory on itself, you can get it from this and call recursively. So I think that's the main difference, is that it's easier to do it this way when you're going to do recursively, because you're going to have on each node the children. But if you are updating the tree node by node in the way that I'm thinking about doing, then I think it doesn't matter that much. As long as you have the name of the parent, that's the only thing that matters, I think. Because the name of the parents allows you to find the node on the... Maybe I don't even need the name of the parents. I think I need the name of the parents. So I need a way to find... but if I cache them, I think I just need the path. If I cache them as the way that I was talking about there, then I need only the path, I think. Because then I can look on the map, I get the pointer to the tree item, and then I add the tree item. I'm probably gonna have to think about, like, so I was thinking, if you don't have the tree item on the map and you try to add for whatever reason, then either I'm gonna throw an error, or I can just add directly through the roots. But I think probably throwing an error, because usually what you should have, the only exception is gonna be the first node. So on the first node, I can think about what should I'm gonna have to think about what is the best way to deal with the first node. So maybe I can do... It's probably easier to just build the stuff first, and then I'll think about as I go. So on the event here from the view, as it's loading everything, then the presenter is gonna have two functions, I think. So the first one is gonna be to check to see if the node exists on the cache. So I think I'm probably gonna use an RU cache. So as the scan-u directory is putting the nodes on the queue, it's gonna check on the cache, because it's also gonna put the nodes on the cache as it's building the tree. Because I think you need... Because the way that they're doing now is they are building the classes, and then they delete the root nodes, which has the entire tree with the states, after they emit the signal. So once they complete loading the full tree, they send the signal to the front end builds the tree, and then they delete the full tree on the back end. But I think it's probably a good idea to keep some heuristic on the cache, so like some size. And to make it faster. It doesn't need to be the whole thing. So if it doesn't find on the cache, then I have a separate function. I think that's probably gonna, these two functions are probably gonna be from the model. So the presenter is gonna call the function from the model. So first try to find on the cache, and these ones need to have mutex as well, I think. So most of them need to have some sort of mutex or something to stop, because they're gonna be like shared places in memory, I think. Because I'm gonna have different threads filling or loading the data at different times. So I'm not sure how it's gonna work with this as well. But then if I can't find on the cache, I have another function that's just use the data access based on the path that's is being passed on the, because the onCollapse function is another thing that's kind of annoying, but the onCollapse event is on the tree class and not on the file system or on the view, fs view that I have there. So I'm gonna have to find a bridge between the two, I think. Either I can probably change the tree class and then just send a signal or do something like this. So every time that a node uncollapse, I figure out a way to get the name or the metadata that matters for the node, and then emit the signal with that metadata, and then put a fallback function on the presenter. Then the presenter passes the information to this one. This one adds the thing to the data structure, adds the thing to the cache probably, and then returns. So it checks to see. I'm gonna check first. So for putting on the cache, I think you need a mutex, because this one could be trying to access the cache as well. I'm gonna try to. At this part, it's kind of annoying because of the nuances of the algorithm, so I'm not pretty sure how I'm gonna do this. I'm gonna copy this initial start from this function. I'm not pretty sure if I think about the uncollapsed paths now, or if I think about it after. I think I created a variable here, and yeah, so I created here. I'm not really sure if I should do this or not. I think the beginning is gonna be this one, so I don't need this part. Then I'm gonna have the queue. I'm gonna put the queue on the class, obviously. I'm not really sure if I did this before. Don't remember. Probably not. Oh, the other thing that I didn't realize here is that the reason why the tree exists is like you can't really encode the tree just with this, obviously. Yeah, now it's obvious, but I didn't realize before. I guess I was thinking about this because I was thinking in this way because I thought that I could ensure the consistency of the sequence of nodes based on the queue, which I think is probably possible as well. But the difference between the hash map with the levels, which are the depth, and the path, is obviously that you can have nodes at the same level, but with different parents, because they're siblings. So that's the problem. But if you can ensure that the nodes are always going to be on the same sequence based on the queue, then I think you can use the two data structures to use. And this is the part that I was thinking about the optimizations. If you can do this with these two data structures, then I think that the trick is probably on the navigation. So depending on the way that you can navigate between the paths, there's probably a way to optimize this by doing some calculation based on the volume of the space that you're navigating. And like you're essentially encoding the state of the uncollapsed nodes that changes the space you're going to navigate as you scroll up and down. So you're scrolling in one dimension, and then the tree data structure determines how the space collapses or expands. So it's like a shifting space based on a plane. So I think that in order to optimize this, you probably can apply a functor or something like that. Because according to the movement, to the unidimensional movement, you have to change the state of the tree if you're gonna try to implement lazy loading. So it's kind of like you have a flashlight on the viewport, and you're illuminating the nodes that are gonna be visible according to whatever heuristic you have. So like the buffer. So I think I didn't put this as a variable. There's a I'm gonna put visible queue, I think, as the name. I think it should probably be public because the presenter is probably gonna need. Yeah, I think, or maybe I can just use getters and setters. Probably getters and setters is better. Do visible queue. It's not that hard actually though. I have to remove this. The thing is you just push the to the queue based on the whether or not it's a directory. And then I have to check based on the yeah, so this is a problem actually. Let me think about this. Because if I'm gonna use the same queue, then like might be an issue when I remove because I'm gonna have to remove. So maybe I don't remove on the. But if I don't remove, then how I'm going to know? I'm thinking about like if I'm gonna use the same queue on the presenter after I emit the signal, then obviously I'm gonna remove nodes as this is iterating, so it's not very good because like maybe it will be empty before and then it messes up the algorithm. So I need two data structures, I think. So maybe I create a queue inside of this function, and then I use the visible queue. I think that's probably better. So I just do queue again. So let me. Uh, actually, let me. So this is another part that I'm not sure. Like I said, I'm not sure if I should do fs model directory or if I should do the other struct inside of this. So the question is whether or not do you need to allocate memory, I think. It's probably easier to just use the model directory for now. I think it's probably easier to do this first, and then I think about it. Maybe yeah, it's just gonna be a difference between like the values as well. So I can change this one instead of changing the other one. I think it's probably better. This one already has everything. I want to avoid. So it's gonna be the same thing here. Let's think. So I push this as is empty. This is the logic that I'm gonna change, so should probably put. So this part I can copy from the other one. So this is getting the current item from the queue, which is gonna be the root in the beginning. Then you remove from the queue. Then I just do the same stuff they are doing here for the iteration. Yeah, I need to copy the stuff from the beginning as well. So the thing that I'm not sure is about the sorting algorithm. Yeah, this is the difference actually. So maybe I have two queues, but then if I have two queues, it's kind of an issue. I think this is the reason why I was thinking about creating the other data structure. It's probably better to create the other one. So like instead of separating between files and folders the way that they did here, I think it's probably better to put the information like on a struct, just the information you need, and then have the same for both, and then differentiate inside of the struct. Makes more sense. And then if I want to do the sorting algorithm, I just do it based on the data inside of the struct, which is basically the same thing. And in order to create the sorting, I think all you have to do is implement the struct you put here. So I'm thinking about calling this from the front end. The front end already has, like, the view already has some logic, some functions that also have like logic just for sorting the directory, and I think it makes more sense to put this kind of stuff on the view. So if I want to sort, I think I do it in the view before I add the nodes. So like I'm gonna receive the data in batches from the queue, then I sort the queue first based on an algorithm from the view, and then based on that, then from the remaining one I add. Or I think it's probably better to sort on the presenter if I choose to sort. Yeah, but maybe it's bad. Maybe it makes more sense because the view already has sorting algorithms, so maybe it makes more sense to put it on the view. I was thinking about the presenter because of the nuance of the queue. It's probably better to just remove all the nodes from the queue right away, and then separate the logic from that. Like, and it doesn't make a lot of sense to make two different lists, I think. Like it would be like remove the items from the queue, and then put them on the other list, then sort the other list and pass the other list to the view. I want to isolate as much as possible the queue so that it decreases the chances of having like issues with databases and stuff like that. Let me think about what is the best way for this. I'm thinking whether or not it makes more sense for now to create the other struct or to just change this one so that it works in the way that I'm thinking about. So like what is the difference between it's just additional data that's the file info is gonna have. I can pass the data that this one needs on the other one. It's basically the way you would do the paths, so that's the reason why they do like this, I think. The paths is the most annoying parts of thinking about because of the like it's kind of like this small annoying details that doesn't matter that much. But you still have to think about it. So that pisses me off. But I think that basically the main difference is that this is going to be the path to the current directories, and then they uh, concatenate to the name of the file, basically, to get a full path. I think I can do this on the first loop. So here they are doing this after the recursion. I think this is for backtracking. So when you continue the iteration, like this is gonna go until it hits the base case. The confusing part about recursion is always the backtracking. I have to think about like when it's gonna hit the base case, and then what's gonna happen with the state of the data after that. And it's very annoying to think about. So I think the base case is probably gonna be here, because like when you hit something that doesn't have like other directory as a child, so this is gonna be empty. So from that point, this one is gonna be like the lowest level of the directory, and it's gonna continue. So it pushes to the parents. It pushes this as a subdirectory from the parents. Is this new one, and then it changes the directory to the upper one. Why does it do this? That's the question that I have. So I'm probably gonna ask ChatGPT this. But like here, it seems that it's changing the directory on each iteration, regardless of whether or not. But I guess it just changes based on whether or not it's a folder. Yeah, so I think every time that it does this, it's going to go inside of the other folder because it doesn't pass any data here. That's probably what's going on. So that's probably why it's changing to the is two dots is up one level on relative directory paths. So I think that's probably why he's doing this. Because when this works, it means that it went inside of the directory, then it goes like until it hits the ends, and then it's gonna backtrack from here, and it's gonna move up the directory so that it is on the same level on the next iteration. So like the next directory on the previous level. That makes sense. So how can I do this faster? I think here on the when is a directory. So instead of pushing to the dirs, I'm gonna push to the visible queue. I'm gonna change the data. I'm gonna add the data that the file needs to the fs model directory. I mean, you should roll this on the RNG. This doesn't really matter that much. Yeah, so I'm gonna change. I'm gonna create another one and leave that. So I'm gonna create the other struct, and I'm gonna put the information that I need there. So let me think about this. What is the best way to do this? I think this is like a separate thing here, and then they register this on ClassDB. The question is, do I need to? Because I'm gonna have to access this on another thing, so I might have to. I have to get the queue values from the. Hmm. I'm kind of too tired to ask ChatGPT about this. because I'm gonna have to explain everything. So it's probably better to create here first inside, and then I think about it. If I can do it inside of here, then I do outside. So it's gonna be, I think node metadata probably is the name I was thinking about. So just gonna copy from SkyDraw. Yeah, the thing is, I'm gonna have to. The question I'm thinking about right now is whether or not I'm gonna need to have a pointer to the parent, or if I just need the path. Let's put this stuff here. So I think file is probably the name of the file. So I'm gonna remove. I'm gonna try to do it without the thing. Just see if I can do it without allocating memory. Because if I can do it without allocating memory, is better. I'm just gonna use this to transfer information. So at the moment that the queue hits the batch limits or the function stops executing, it's gonna emit the signal. The moment it emits the signal from the model to the presenter is gonna use the queue of this stuff here to probably iterate over. I guess I can compare. I asked this to ChatGPT as well, like why not put the elements as in a sorted order, and it said that it's probably worse because it takes it takes n to the power of 2, so, and then to sort at the end takes on log n, just faster. So you would have to do it in each iteration, but if I do it in the end, I think that's probably, it might be better. No, but it's still kind of worse because you have to traverse the entire list to figure out if the thing is on the. So it's probably easier to just start at the end. I think either way it doesn't matter because I can do it inside of the list, inside of the queue. I'm not trying to do it like this. This would be. I'm gonna copy the whole thing and then I'll write whatever it needs. So this is in the situation where it is a directory. So I'm looking here and what information it needs. I think it's just the name of the. So it's just the parents and the name. Yeah, so let me think about this. So the name's gonna be F there. It needs just this, and then on the other one it's the one that it needs more information. So I need the parent path. It's gonna be CD. Is it CD or is it? Oh, the current path is F, I think. No, actually it isn't. F is the name of the file, I think. I think the current path is CD. But I can't use CD, I think. I think I can because I would think about this. And maybe I'll put CD equals the current directory again. So I change inside. I need to do in the beginning of the queue there instead of in the function. So I need to move this to the beginning here. And then I need to do like this. Because I'm gonna push each directory to the queue again, so the beginning has to be inside of the loop here. So it's gonna change. It's basically the same pattern from the other one, but without the recursion. Every time that I push a node to the queue is like a subdirectory, so it's gonna get the. So as I push, I'm gonna change. Or maybe I can change here. I think I can change here. So maybe it's gonna be current dir path. And now I'm not really sure what to think about this. Well, this can be outside. If I wanna do it on all of them, then I guess I should be inside. And now that I think about it's kind of different, so I think I have to do another loop inside of this. Because I need to iterate over all the files and folders in the directory. It's just annoying to think about this. But I think I need to. It's annoying because of the nuance of the access of how it's gonna iterate over. Let me think about this. And maybe this way it doesn't matter because it's still gonna go over all of them. It's just that I'm putting on the back of the queue, so I think that's probably it doesn't matter. So I think I can do it like this. I do it based on the current directory. No, but actually I can't do it based on this because I think that's one of the difference. We should do it based on the F. So if I can check if f is a directory or a file, because I think that's maybe it does work actually. I think the problem with this is that for each one, I think I need two loops. Like for each one, I have to loop entire over the entire thing. So I do need two loops, I think. Maybe I should copy this again and then put inside of. Hmm. Now it's probably better. Because on each level, we need to loop over all of them. So here is the part that I put the. Instead of putting on the files and folders, it just differentiates what metadata I put on each one. And the problem is that the files is going to push based on the name as well. I think for the files, so now I think I have to think about like how is the path going to change in a different way from the other one. I think I need to change the directory outside of the loop. And then I don't need to go up the directory because I'm going to level by level. So like the next node on the queue is gonna be like the next subfolder. So this is gonna be the visible queue thing. The name is F. And they get iteration and they push F. So the main name's gonna be F. And the path is gonna be the current path of the directory. I think the current path is like it changes based on this. So I think I need to change here before it begins. I should be before this. Then I don't know if I put. I think I have to put the current dir path. Oh, this is gonna be the parent path. So what is the path of the directory? And they didn't put paths on the directory. I can just look into the view. Pretty sure that they do, because they use on the update tree, I think. Oh, create tree. Oh, I do remember there's something weird with the path, because it is on the function. They do it based on the name to get the... I had to change this because I changed the way that they did it. So on the original one, they have the hard-coded root of the project, which is the res directory. Then I had to change this, and I had to change the function to make it work. So they traverse from the current one. So obviously, I think it's probably better to put, as I create the thing, I just put the name of the, just put the path. So I have to translate the way that they do this. So they're just joining. I think you just path join to the name of the thing. So it's gonna be the same for the folder and the file, I think. I think it's just thinking whether or not I can do it from the, like, which one is better. Actually just realized that this shouldn't be, like, this queue shouldn't be from metadata. It should be maybe the path. I think this should probably be the path. Yeah, so but I'm not really sure if I put the path of this node. Or if I use the dir access to get the current path. Well, cd is the current directory. So maybe just cd is better. So the cd path join. But the problem is that I need to do we need to do basically the same thing. I need to use the same for both, I think. So the parent's gonna be cd. So either I put cd on both, which is the current directory from the DA, or I put this path. But I think it doesn't matter that much. Actually, it does matter. You know, like the difference is what I'm gonna push on the queue. So I have to understand what is going on here. So when they get the F, they're pushing. I think that the change there changes relative to the whatever the current one is. So it's gonna be the relative path, I think. So I'm probably gonna push the F as well to the Q. So because I'm gonna push the F to the Q, I think I need to use CD because use CD on both because the current dir path here is gonna be the relative path, I think. Obviously, I'm only gonna be able to know after testing this, which is kind of annoying, but as I have parent path. I just realized that I have to move this. And I can't do it on the path. This is from the thing. Yeah, whatever. And the other is stuff I wasn't using, I think. It's probably better to put both first. So now I do the same thing on the file, just get the only thing that I'm gonna do. So I think I do it at the end here, at the end of the loop. I check to see if the batch size was hit, and if it is, I emit the signal. I'm gonna copy this stuff that was getting here. So the file is gonna be the f, which I think is the name. So name is f. Not sure if I need. I think I should probably. So I'm gonna do it separately. Then I'm gonna see what's common between the two, and I'm going to move the initialization outside. And then just add the additional information depending on which one it is. I think the file is the name, which is here. The path is cd5. So this is gonna be f as well, I think. So it is correct. The parent path I think is the same as the other one. The empty is based on the path. So maybe I should do like this on both. It's gonna be false. And the type. I'm not sure why has both, has two times this. So it's pushing to the as a file on the feeder. So I think that's it. Let's now move this outside. And this one we need. And this one is just for that thing. Small element, I think. Oh, so this one is not gonna push to the queue. So here I think I have to. I think I didn't need to change the directory because it's gonna change the beginning. Yeah, so I think that's it, and then at the end I put. So I should emit the signal both on both situations, I think. So this is as iterating on one level. So where is the? So obviously there's something missing here. I forgot bracket somewhere, I think. Or maybe at the end he needs. No. So why is it going there? Oh no, it's just an indentation thing. I think I need to put this in the end here as well. Maybe not. Because if he hits this part and it didn't trigger, then I think actually on the end of the function. Because if it didn't trigger, then you need to send. So I'm gonna create another signal to send. So I'll be right back. When I come back, I'm gonna see if this makes sense. So I'm gonna try to create. The only way to be able to test this is I'm gonna create the signal first. So in order to add the signal, use the add signal macro. Then I'm gonna put the signal here, and then I'm gonna listen to the signal on the file system presenter. Then I'm gonna create a callback function, and then I have to close the first step there. And then I'm gonna remove or comment out the parts that I'm calling scan for now. Or actually no, I'm gonna change because since scan is using the threads, it's gonna be annoying if I do everything from the beginning. So it's better to just change instead I comment out the scan directory from the scan file system function, and just call the new function that I created instead. So I'm just gonna call scan the same way. Then it's gonna emit the signal, and then I create the other function on the presenter. The presenter calls the view. So I'm gonna have to create the function on the view as well, which is gonna be basically the same. I think I'm gonna keep a hash because it's easier on the view first. So I'm gonna do it based on a hash. The thing that I was thinking about is whether or not, because obviously I don't want to check every time that the function is called. So maybe I should have another function. I should have the, but maybe I need to check anyway. Like I'm thinking, I'm not really sure which is the best. Like to separate the logic from the. So I have one function that updates the tree, and I have one function that creates the tree from the beginning. Because I don't want to check to see if the function has the node on the hash each time. But maybe I have to. Either way. I think I probably have to either way to throw an error. So I think it doesn't matter. I'm gonna use the same. Probably better. So I'm going to create a function that receives a batch from the presenter. So the presenter is going to call the function directly, because the annoying part about this, the other annoying part is that if you're going to connect the classes with the signal, you are bounded by the variant type. The variant is a union type, which is basically the conjunction of sets. So like a union is kind of like using the OR operator, where you just add additional types. So like each type is a set. And then a union is going to be when you put a lot of different types on the same set. So it's like a type that contains all of them. And this is basically what they created on Godot, is a variant class. And they use C++ functionality to translate between the types. So based on the built-in C++ functionality allows you to construct different constructors for the different types and different stuff like that. So basically different functionality. And this is the system that they use to translate, to serialize information on the scene, and also to translate the information on the signals. So what's happening when you send a signal, the way that they parse the callback function and the arguments and stuff like that, the types, is by using the variant. So anything you want to pass between nodes using the signal, you're going to have to implement something that the variant supports, which is basically everything. But if you want like a custom type, which is what I'm doing now, you have to inherit from object, and then you have to pass as a pointer, because that's the only thing that variant supports. Or you can change the variant yourself, which takes a massive amount of time. It's very annoying to do. So obviously the easiest way possible is always going to be to inherit from object, and then the problem is you're going to have to use memnew to create the allocated memory on the heap, and then you're going to pass on the signal as a pointer. And the reason why you can pass as a pointer, this is another part that is kind of complicated, but I think that if you pass as a pointer, then C++ is going to be able to figure out, because the only thing that matters is the beginning of the memory place, I think. So if you pass the data as a pointer, what C++ does is like it finds the beginning of the class, and because it puts every memory for the whole class on the same spot in memory, it doesn't slice the object. But if you pass as a value, then C++ is going to cut the functionality from the derived class, because there is an inverse relationship between the type and the object. So like the subtyping is like stuff related to polymorphism, which is basically many forms. So the types are basically sets, and the relationship, the way that the types are translated, is going to be based on the logic the compiler has to translate the different types. So different languages are going to have different paradigms to encode this relationship, and I learned a lot more about this when I was studying Haskell just not that long ago, which is still very confusing to me, because Haskell has a different kind of thing, which Rust also has and other classes already have, which is like a fundamental pattern, but it's not used on C++, and I think Python and JavaScript don't have as well, because Python and JavaScript don't have types. But it's basically the concept of interfaces, which is similar to abstract class, but it's not the same. But in Haskell, they allow you to implement a different functionality for different types. And in C++ it's different, because it's based on the classes hierarchy, the class hierarchy most of the time, because it's the subtyping polymorphism thing. And what this means is basically that the way that C++ is going to view is every time you create a type, you're going to create a bigger set than the original one. So like this would be like the type B, which is a derived class from type A, for example. And the type A is like because it's the base type, it's like a smaller circle. So every time you create inheritance, you're creating a bigger set that encapsulates the original one. And this is the relationship between types. So for the compiler to figure out what types it has to do with logic and deduction of proofs, because programs are proofs and types are propositions. So It's still kind of confusing to me. I have to study more about this, but it's basically the name of this. The first time that someone saw is Curry-Howard correspondence. So like there's a fundamental, obviously now it's pretty obvious for me, but there's a fundamental relationship between mathematics and computing. And the Curry-Howard correspondence is what describes the relationship in some areas. But basically the way that I view is that mathematics is a bigger field, and computing is like smaller, but they are both doing calculus basically. So like computing is mathematics, but is not the whole thing because it's the lower resolution of the whole thing, because mathematics is just a way to express the geometry of space-time on the under a reference frame of a network. So the network of the field of experience creates the symbolic abstract representation of geometry, which is a lower resolution of space, which is connected through time. So imagination, and I'm not 100% sure if they knew this, and also I'm not really sure if this is true or not, but I think it makes a lot of sense. But I think they probably knew it because of the name that they gave. So like imaginary numbers are mapping out the abstract space because the space and imagination are intrinsically connected through time. So it's a funnel of information. So computing does encapsulate the imagination space because of the lower resolution. And mathematics is just the symbols that are a consequence of this relationship between these different planes that happen across time. It's a projection of symbols that has axioms, which are assumptions that of the network of the experience that experience itself. So computation is just using a different form of representation to create the abstract symbolic representation, which mathematics has. But basically, I don't remember why I said this, but I think that from what I'm saying, the way that the compiler is going to figure out, this is going to traverse basically between the sets, and this is basically logical proofs and logical deduction is what it's doing. So on C++, it's going to be based on this subtyping thing, where every time you have an inheritance, you're going to create a bigger set from the original one, and the way the compiler is going to figure out the types is by traversing deeper inside of the sets to figure out. So a union would be like creating a bigger set where you put several different other sets inside of the union, and then the functionality of the class is going to determine how to deal with each type. So you're basically encoding the functionality using C++ built-in tools to allow you to figure out how to deal with that type. So like this would be a variant. So it's a union of types. Like in Godot, the name of this is going to be variant, but it's basically the same pattern. It's a variant class. And the functionality of the class itself, the variant class, is the thing that allows you to it allows the compiler to figure out how to deal with the class. So when you're passing the type on the function, you're going to pass as a variant. But under the hood, what's going to happen is that the compiler is going to see that the class has a functionality to allow you to determine, okay, what's the path between this bigger set here to whatever the bigger set supports inside. And then based on this, it's going to basically walk the path and then create the class based on that. But the problem with this thing here of the class inheritance is that the relationship between types is like this, but the relationship between objects is different. So the object is whatever is inside of the set. And this part is the one that is confusing because obviously when you're creating an inheritance, the derived class is going to have more functionality than the base one. Actually, it's the other way around, now that I realize. Yeah, so when you're creating the types, it's the other way around. The types, like the base class is going to be the bigger sets, and then the derived classes are going to be inside of the sets. And the compiler is going to figure out by traversing the path. From the outer set, it's going to figure out the type. From the outer set to the inner set. But when it comes to objects, it's going to be the exact opposite way. So, because obviously the object on the derived class has more functionality than the base class. And because of this difference in the gap between the sets, you're going to have what is called object slicing on C++, which basically means that if you pass the value of the function, you're going to lose the functionality, which might cause problems. So, but as long as you pass the pointer, it doesn't happen because the pointer is going to point to the same place in memory. So the compiler is going to be able to figure out from that point, I think, But this part I'm not 100% sure. But if you have the object here, so the A would be an object of a base class, A, and the B would be an object of B class here. So the compiler sees it in this way, but if you're passing as a value, the actual relationship is going to be this other way. So it works on the type checking, but it fails on the runtime because of the difference on the delta between the classes. And this is the object slicing part. So I believe that for that reason, because it's the same path, if you think about it, so like the variant to the other types is going to be the same thing. And I think for that reason, it makes a lot more sense to support anything that derives from an object, because the object class on Godot is going to be a class that is supported by the variant, so you can figure out. But if you have a class that inherits from object, then you're going to fall into this object slicing thing here. So that's why you need to pass it as a pointer. But the annoying thing about this is that the scope of the variant is going to limit the information flow between classes, because it is what supports the transfer of information between different nodes, so the signals. So in order to not be trapped by this and to simplify things, you have to emit the signal without passing anything and then connect functions directly, which is what I'm trying to do. So I'll be right back. So I was gonna add the signal. I'm just gonna copy this. So I think that's our batch size heat. And this stuff, these macros here, is basically used to register everything on the class DB, which is the class that keeps track of the types on Godot. And they're gonna use under the hood the variant class to translate the information between the runtime environment to the disk, writing to the file. So I have to think about like how I'm gonna do this. Maybe this I should ask GPT, because that's the part that gets confusing. Because it doesn't make sense to put like a safeguard on the queue that depends on the thread because then it defeats the purpose, obviously. Like it has to be something that allows me like how I'm gonna. And this is the problem. And maybe I'm gonna have to do it in a different way because of this. Like, because as this function is running, it's gonna emit the signal, it's gonna call back on the presenter. So, but the presenter has to use the same thing. So maybe I have to send as the thing, but then that's the problem, the whole problem with the variance thing. It would be better if I could send the information as the inside of the signal instead, because then it becomes another thing. Hmm. But even then, I think it's kind of like the same problem. The question is how can I continue to change the data structure as the other class uses? Hmm. How can I ask this to ChatGPT? I'm not gonna push the alpha as well. I'm pushing the front matter. I see. There are gonna be problems. I have to think about how I'm going to. So how can I ask this to GPT? Yeah, the mutex is part of the answer. So maybe I should study the string name again. So I think you have to put on the. And there's another thing. I think I have to create. Actually, it's because this one doesn't have smaller. Yeah. This one. Subsystem. So I'm gonna look into the. Maybe before I do this, I just change the scan file system. So the way that it works is that it's gonna run scan, then scan is gonna initialize a thread, it's gonna pass scan file system as a callback, and then this one is gonna call the scan directory, and then it was emitting the signal at the in the process. And I don't think I need to change anything for now. Actually, I don't need to pass through the function. It just scans from here. It's probably better to leave the function like this. I think it doesn't make a lot of difference. It's probably better to leave the function as this because then maybe I can call in some other situation from another directory instead of the root. Don't know if it is. Yeah, it's a different one. But this class I know that it uses mutex, I think, some parts. And the other one, so like this one has a macro that is kind of confusing that I saw the first time. Is this thread safe class, but I don't think he uses this one, as far as I know. So that's the part that I'm not like I don't know for sure how it works. But I think I could use directly this one, but then I think I would need to use the same thread, maybe. I don't know how like it works. From what I've seen before, when I was studying this, the purpose of doing this is that it allows you to, and maybe when I call the, I think I just realized I need to put the macro there, I think. But it basically creates a class that is gonna build and destroy the thread, I think, based on the scope. So as you construct and destroy the class, it builds and destroy the mutex, I think. So it makes it easier. You just have to put this thread safe method inside the macro inside of the function, and then it prevents from being accessed, I think. But the thing that I'm not 100% sure is about the relationship between the mutex and the lock and the thread. Because like from that function I'm using a different thread, I think, from the function. So that's the problem. And this works based on macros that they have there, so the definition is kind of weird as well. I think it's on this. Yeah, so here it seems that it doesn't implement anything, but it is because of the macro. So this time the VS Code doesn't hint correctly. And the actual implementation is going to be the one on top there. But it's initializing threads, I think. So initialize this class. This class has a mutex inside. So it's gonna be basically this one, I think, on the actual example there. And this is gonna be std mutex. This part is the one that is confusing because it uses this type here to initialize here, I think. And it's based on the templates. And it depends on what compiler you're using, I think. So in my case, it's probably gonna be std mutex. But I think it's basically going to lock and unlock as you build. But the thing that I'm not sure is whether or not I need to call. So I'm gonna ask this to GPT. So whether or not I need to call the function from this thread. Like basically, so mutex I think is something that allows you to put like guards on the. It's like semaphore. It allows you to put boundaries of where you want the data to not change or to be synchronous. Because the thing that forces this sequence of events is the memory. And is the thing I'm going to show again, which is a very good response on Stack Overflow. So, like the threads encapsulate time, and memory encapsulates space. So when you're using multiple threads, it's like you're curving space-time, because you have different points of time on the same space. So you gotta make sure that the space is the same that the threads have, and that's like the synchronization. It's memory consistency, I think. So in order to achieve this, you have to use these guards to make sure that the compiler doesn't reorder the instructions to change what's going to happen. So basically telling the compiler to not change the instructions so that the memory is the same, I think. Or memory is consistent. And then prevents the threads from accessing the same place as well. Because like, yeah, the situations where you have a problem is when one thread is expecting one data, but then the other one changes as the first one is executing, and that's the database condition. This is basically, and this is response from this link here is very good. I highly recommend reading. I wish he had more resources on this, and he shares, I think, a paper like this one here. But I haven't found many. So there should papers that are very good here. I couldn't find many, but I didn't look too much into it as well. Maybe I will in the future. But it's basically this thing here. This is my interpretation of what he's saying. Maybe I'm wrong, but I think that's how it works. So like each dot here is like a thread. So when you're executing only with one thread is when you have the first case where you only have a flat plane. But the problem is when you have different threads, it's like each one is going to its own timeline. But if you try to implement multiple threads with the same space here, then you have inconsistencies because the perception that each thread has is different from the space, which is the memory. So that's why when you're using multiple threads, like you're bending space-time. As long as the memory is consistent, which is very interesting. I think this is the class, is mutex. Yeah, so this is another class. So you're gonna pass the original thread, which is this variable here. So like this basically initializes this thread on the first variable. And so it's like, but this is the question, I think. So this is a mutex. So I guess it's just a easy way to create a fence, but the problem, so I think the question that I have is whether or not you need to call the function from the same. So basically, I'm gonna ask this to the. There's both. What is the relationship between a thread and mutex. Do you need order to use a mutex property? Does you need should be use? Not sure what's the best way to put this. I think here, pretty sure that this is gonna be the class, which is here. Yeah, so when this class initializes, the constructor of the class is gonna take whatever mutex you pass here, and then it's gonna lock, which is the thing here. So the construction of the class is gonna automatically lock the thread. It's gonna create the unique lock depending on the STD with the mutex type you have, which is the same type here. So this one is the one that is going to be created outside, which is this mutex here, I think, but it's going to be based on the class, I think. So it's this std mutex, which is this thing here. That's the type of the class. Basically, the type of the mutex you initialize here, it's going to be mutex in this case, std mutex, I think. This is the class that initialized the std mutex. So that mutex is going to be this mutex implementation here, which is going to be this class. So as initializing this class in the beginning, this class has the mutex as the member variable here. And then it uses this one on this one. So this type mutex t is going to be this mutex implementation here. Then it's going to access this, which is this thing here, which is this type, which is the template of the class. That's why I think that there should probably be an easier way to do this, because it's very confusing to understand. And I think that the purpose of doing this is that it automatically locks the thread, or it automatically implements the mutex. But what I don't know is that if I use the other thread to call the function, because they are not calling the function from this thread that is initialized with this macro, which is this thread safe here, they're calling the function from this thread here. So that's the thing that I'm not something sure. Basically, that's what I'm trying to clarify is what is the relationship between this thread and the macro. So I'm gonna think about a way to ask this. So based on what it's saying, as long as you put the Q on the function that is going to use the, as long as you put the mutex on the function that is going to use the Q, doesn't matter. So the thing I was thinking about is whether or not I should create another function on the model to translate the information from the Q. There's two questions. One is whether or not to translate the information from the queue to another structure to pass everything to the view, or if I should loop inside of the structure on the model and then call the function on the view to add one thing at a time. Yeah, I could have a function on the view that puts like add a node to the tree or something like that, and then I loop over the list on the presenter, and then I call the function for each node. I think that might be better, because then I don't need to. Yeah, I think that's probably better actually, because then I can make the function of view only based on one thing, and I don't need to expose the data structure. No, but yeah, if I'm gonna use, then I have to pass everything anyway. Yeah, so I think I need to pass, like the easiest way to pass everything anyway, so it's probably better to pass the whole thing. So if I'm gonna pass the whole thing, it doesn't make sense to pass everything as a list. I think probably because then I don't need. The question is, if I pass as a list, then because this is the issue, like it doesn't make a lot of sense. Like the easiest way obviously would be to have a getter on the model to get the queue, and then I just call the function from the presenter and pass the queue to the view, to the function on the view. But the issue is that it's going to be the same queue, so I need to make sure that I remove the items. But then if I create another data structure, it feels kind of dumb because like you're looping twice, which is not very good. So I'm gonna ask the question about the macro. Not sure if it's gonna be a good show now. It's basically this situation here. So like as this is running, it's going to pass nodes to the queue. And then as it passes nodes, when it hits the batch limit, I'm gonna have this function on the presenter that is gonna use the same queue to send the data to the view. So the question I have is how do I make sure that so for that reason I think just intuitively it makes more sense to take one at a time, because then even like if you put the mutex, it's gonna prevent the race condition, and it's going to be unlikely you're gonna have unpredictable behavior between the nodes that you get each time. So if I take the whole queue, for example, and pass to the other one, then there might be duplicate nodes on the next batch, because yeah, so like it's gonna let's say I get in the first one is gonna be 100 nodes, so I get all of them. Then as I put other items, I don't remove. But if I did based on the index, wouldn't be a problem. But I think it's just easier to have an algorithm on the presenter that just pops the nodes on the queue, so that way it's like sending the information one by one. And then I create another data structure inside of the function. So like I get the queue from the model. Then I loop over the queue, pop the values, and put them on a vector or something, and then I call the function from the view with the other data structure. And I have to think about what is the best data structure to pass to the view. So I think on the view, I can have two different functions. One that updates by batch and one that updates one at a time, and then I call the one at a time instead of the batch. But in case of if I want, I can call directly the one that updates one at a time. Yeah, I think the best way to do it is on the model probably. So on the function that gets called, I call another function. So like after I emit the signal, I have a callback function on the presenter. The presenter calls another function on the model, and then that function extracts the value from the queue using the same mutex, and then it passes that into either a copy or another data structure that the presenter is gonna use to pass to the view. That's probably the best way to do it, because then the mutex is on the same class and decreases the chance. So like I just pop from the queue. That's probably the way to do it. So according to ChatGPT, is saying that as long as if you use the macro, it works for the other thread, because the mutex is just going to ensure that the memory is not accessed based on the. I think that the mutex depends on the argument you pass. So there's different kinds of mutex. I'm gonna look into the string class. The string class uses like there's class that they created that implement the mutex. That depending on the argument you pass to the mutex is going to have a different restriction on the memory. So like some are more restrict and others are less, and you use different kinds of things that in enum. So the different kind of enum value should determine what operation you're doing. So like either you're loading memory, which means you're reading, or you're storing, which means you're writing, or you're doing both on an atomic operation. And then there's another one that is the more relaxed way to do it. There's a different value there. But I think it's a difference. I don't remember really well. Yeah, so it uses this mutex lock here class. And so I think when you're stepping through that, it shows there. It's basically the same thing, but the other one uses macros to make it easier to write. And the other one automatically, I think this one probably automatically creates and deletes based on the constructor of the class. So when the function goes outside of the scope, it's going to destroy the lock. Or you can call this. I think this is usually more useful when, like, calling the function directly is usually more useful when you want to have like inside of the function on different specific spots. It goes to the wrong place because of the conditions there. Like it does either one based on the macro. It selects which one it's going to use. Yeah, so if you're using no trans, it's going to go to this part of the macro, which means it's going to implement this empty classes. But if you have threads enabled, which is this macro here, and this is set on the build time by scones. So because I'm thinking about the thread case, it's going to be here. And ask if mutex works even if you're not using thread. Because obviously it's going to be like kind of asynchronous either way, because they're going to be based on the signal. I think most of the time they're going to be called at the same time. I'm not pretty sure if there's another way to do this that you would like decrease the amount of. I think most of the time they're going to be accessing the same spot because they're going to run the same time. So maybe there's a better way to do it that it would decrease the amount. I think like either way you have to transfer the information from the data structure. And if I pass, the only way is through the signals, but that's very annoying. Maybe if I have a signal that passes the information that it needs to build, but I think that's overly complicated. Like I could have a signal where I pass the information that I need to create the metadata, the node metadata, and I have another function that based on that signal creates the node, each node and pushes through the queue. But it's gonna be the same thing, just extra steps. So I think Just put the macro and then I test to see if it works. So I'm gonna ask what question. Yeah, but if there aren't multiple threads, then it's gonna be. I'm not sure actually. I think that if there are not multiple threads, then it's going to execute the function on the same. So it doesn't make sense to think about. So like right after it emits the signal, it's gonna stop the original function, scan new directory, and it's gonna call. Or it depends on the way that the callback is structured on the signal. But I think that if you don't pass callback deferred as a flag, inside the emit signal, it's just gonna call the callback functions right away. So the only difference would be that on the threads it's impossible to access the same place because it's gonna execute at the time that it emits the signal instead. So I think it doesn't matter that much. So now what I have to do? I'm gonna go in the review, then I'm gonna think about. So I was gonna ask what is the best. So the other problem that I'm gonna have later is that like I'm building the like I think that doing this way is better because it is easier first. So I have to see if it's gonna work to begin with. But the other annoying thing is that if I do the cache, like in order to restore the state from a previous scroll position, you have to cache the value on the scroller, and then I have to restore that. And there's also the uncollapsed paths that I didn't put in the function. So I'm gonna have to use both of those things. I forgot to put this as a variable there. I was thinking about putting as a boolean. Because this is what's gonna determine how I'm going to, what makes it collapse or uncollapse is the tree. I think, yeah, this is the part I didn't do there. So if, so I think I'm gonna do this later. But if there are uncollapsed paths, if there's a previous cache state, I have to set the the easiest way to do it probably is and already put the variable. You should make it as a member of this class, and then you just set based on the configuration of the presenter. So the presenter gets the previous configuration, the cache configuration, which is the previous state from last time that the file system was used. Then it uses that to set the state of this class based on the member variables. And then the function is based on the member variables. So inside of the loop here, I check to see probably here if this is uncollapsed. So if this exists on the uncollapsed directories, so either do a hash map, probably a hash map, or a hash stats. The thing is that the way that it's saving is based on a vector of strings. So I'm gonna have to see, but maybe I'll do another function for this, like see how to start loading or populating the queue from what's visible, or finding a node up until a certain point from the top node that is visible. And this part's the one that is very annoying. So like you have to traverse backwards, or like you get the top node that is visible, then you calculate depending which is the directory structure, like you go back from that node. So if it is a file, for example, you're gonna traverse on the same level, and if it is a directory, or if like is a file on the top of the directory, you're gonna have to traverse to the upper level and see if it is collapsed or not collapsed, and then like you get to a certain point based on a heuristic of what is the buffer we want to have above the stuff that is going to be visible right away. Then you get to that node. Then from that node you traverse down. So like based on the limits of the nodes you have. So let's say like based on the GUI size, the viewport size is going to be 50 nodes that are shown. Like you have to calculate that first based on cache. Then knowing that, you do the batch size based on a heuristic on top of that. So you do that number as the base value, and then it's going to be that number plus something that's going to be divided by 2 because it's on top and the bottom as the buffer size. So based on that number, the final number, you have to traverse the tree from the top, then get to the points that is going to be the starting points, which populate the queue to begin with. Then populate the queue, and then you have to go from the top to that's why I think it's probably better to have different functions. So like if you have a previous configuration, you start this function on a thread, and then you start to create the entire directory on another thread, and then you use the cache is going to be the thing that is used to so this is the part that I'm not sure. This is going to depend on the for that reason, I think it's probably better to do the way that I'm doing now, just implement stuff in the beginning, then think about this later. But I think that there needs to be, it's probably the cache, like there's 2 different things because it's a hierarchy, like, and I think that's just a fundamental property of physics, of space and time. Like, I think this is something that a lot of people don't understand as well. Like, the reason why communism doesn't work is because you're always going to have differences on the universe, because that's what time is. So like time is a difference in state, so it's a measurement of the difference in space, which is a difference in state. So because of that, you're always going to have a hierarchy, because otherwise if you only had one state, then nothing would change. So because of nature that you have different states, it creates a hierarchy because it's more likely, like you can only go from one state to another state at a time, but you always have the possibility of having more than one state. So because of that, the perception is a funnel. So like it's the funnel of programming. I think it's basically the same thing from game programming, where you're gonna have the views like the matrix is like projection, uh, and that's basically what time is. It's like a projection. So it's a hierarchy. So I think it's just a fundamental property of the universe and the laws of physics that whenever you want to optimize for speed, usually you're gonna converge towards a hierarchy. So that's basically the ON, the relationship. So the more memory you have, the faster it is, but then you spend more memory, and the less memory is lower. And then the fluctuation of them is the frequency of awareness, which is space-time, because it's a projection. So the way that I think about this is that probably to make it faster, you need to have this hierarchy. So the faster and more effective you want to become, the more granular it has to be the complexity of the funnel of information. So in this case, it's like the simplest version possible, where you have a queue. The queue is the data structure for the fast access and the fast load. And then you need another data structure that's going to work as the base. And then the complexity and the nuance depends on the way you're going to update or load the state from the beginning to the end. And it's directly reflected based on the state of the viewport. So is the case is a snapshot of the projection of the user. So the viewports is like a snapshot of the geometry of space-time, which is determined by the data structure you're visualizing. And then the trajectory you take to update that is the algorithms you create and the relationship between the different data structures you use to create the funnel. In this case, I have the queue on the top of the funnel, which is the fastest one, but has less memory. And then I think I need, that's why I was thinking about the LRU cache to work as the base. So I think on the situation where I have the configuration, I initialize one thread to start the state from the configuration and pass things very fast to the view, so the initial buffer. And then as I do that, I create another thread that starts the state from the root of the directory. And then there needs to be another thread that reacts to events. And the thread on the events is synchronized based on mutex. And it checks the cache first, which is the longer, the one that takes more time, but is faster, which is the cache. So ChatGPT thinks that vector is the best. As this is another thing that Godot, not Godot, ChatGPT says is that the standard queue is faster, is more effective according to ChatGPT than the list from Godot, but the list maintains more consistency with the way that Godot works. But obviously, I'm not. There's no way for me to know if that's the case or not, because I didn't spend too much time on. I know superficially the way that it works there. They use a element, I think, class inside of the list, and it's just a basic, like traversing through the pointers, I think, and then managing memory. The part of managing memory, I'm not 100% sure, but obviously it's gonna follow the stuff that Godot has on the other ones, which is basically macros. But underlying, I think they still use the C++ standard library class or functions to allocate memory on the heap. I think the main difference from a talk that I saw from the I think it's a tech lead or something like that from Godot is that the philosophy that they have is to always increase memory and never delete, which takes more memory but is in general in general faster. So like the vector, for example, always expands in memory and never goes back. And usually, I think the standard vector it deletes memory as well. So I think that's the main difference. So I would assume that the list with the list is probably the same thing, but there's no way for me to know for sure if ChatGPT is hallucinating when it comes to that. And Godot's list is worse than the standard list or not, or standard queue. So in short, it recommends the queue for the it recommends the list for the queue and the vector for processing. I'm gonna copy this function and obviously just use the vector from the. I'm gonna put it on top of this. Oh, there's also the changed stuff that I'm not gonna think about now. I think I'm gonna try to figure everything else first. Then I'll think about how the change is gonna be. Because there's always threads. After you initialize everything, there's a thread running to check for changes on the file system. I think that uses the operational system to see if there was an external change to the directory. But the thing I'm not really sure is that if you have a very large directory, it's going to take massive amounts of time to traverse everything. This is the thing that I think is very impressive on VS Code, that it seems that it loads extremely fast, even on very large directories, so it's testing. And even when you scroll very fast in the beginning, it still loads very fast. But I don't understand how. So after I test this, I'm gonna see if it works the same. Because if you do the math, like I think is in general is good to take around like 10 milliseconds to load each file or each item. So if it's taking 10 milliseconds and you have a directory with millions of files, it's still gonna take hours to load everything. So it's still slow because there's a lot of stuff to process. So I'm not 100% sure. I think that the reason why it's fast is because of the lazy loading, and because usually it's very unlikely that you're gonna have too many levels of depth. Because you still, according to ChatGPT, I'm not 100% sure, but I superficially looked on VS Code, and I think that I'm almost 100% sure that they use the 3 data structures to do everything. So you still need to traverse from whatever is being shown to the roots of the folder, and then like create the minimum hierarchy possible until you get to the whatever is being shown in order to maintain the structure that what's going to be visible, like to create the levels. So I think that's probably what they do. They load the minimum amount that is necessary to create the accurate structure of the uncollapsed folders until what's visible, then they load what's visible, and then after that they start loading everything else, and then they react based on events and they cache everything. So like 10 milliseconds would be 100 files per second, and then if you have millions, it's gonna be hours. So even if it is decently fast, it's still gonna take a long time. So I'm not really sure how I think they have a file watcher or something like that, according to ChatGPT. But also I've looked into it a little bit, and I think that makes sense. And the only concern that I have is like what happens because this requires to pop the items. But I'm using another queue here. Yeah, so that it doesn't matter. Yeah, so I think that doesn't matter. This one I'm only pushing here. And compiles. See what happens. I think since it is here, it should be like this. And I should put these functions. I think the scan new director is not. Uh, and this might be a problem actually. Yeah, just realized. So I can't subscribe these functions on the class DB. But I think as long as they are used internally, it doesn't matter. And the reason why I can is because of the variant. So scan new director is also not registered on class DB, I think. And so this is probably from standard vector or not. Empty is not a. This might be is empty. It's interesting that here they are getting from the back. Maybe I should change this because I'm pushing back. No, but I think it's probably correct. So let me review this. So it's going to start. It starts with the root directory on the queue. Then it pops the root directory. It pops, I guess, the root directory from the queue. Then it pops. And it changes to that directory. And then it gets the current directory, starts iterating over there. So this iterates over the current level. And this gets the path for the name of the folder or file. It puts here, and then I join with the current one for the path. The parent is gonna be the CD. This is skips. And the thing that is missing is the uncollapse. But like I said, I'm not really sure if I'm gonna do this later on another function. I think I have to do it on the same function, but I'm gonna have to change everything. Because it needs to go right away instead of going through the natural thing. Not sure if recursion would make sense. I think I can do it with the change directory here. And this I'm not 100% sure about this, but I think that it is correct because it seems that's how they do it here. I think this z gets is gonna be the f, so it changes based on the name of the file. So I think it's fine. I think if there is an uncollapsed path, uncollapsed node, then instead of pushing to the queue, I just loop over right away. So the thing is that it's gonna be the same pattern, so I'm thinking about whether or not it's gonna change, because it makes more sense to put it on the function, or if I should call the function recursively. So I do like if so I have a way to say whether or not it's collapsed or not, and I just call the function. The problem is the backtracking that confuses me. I think it would work, because then when he backtracks, he's just gonna continue from the last point where it stopped. So I think should probably just do the recursion. But for the uncollapse, I'm gonna fix the other stuff first, the stuff outside of this class, and then I'm gonna see what is the best way to. I was thinking about. I think I created on the visible queue a function to translate from a vector to a hash map, so it's easier to check. Yeah, but I think I should think about this after I figure the whole thing out, like the rest of this stuff. Because it might be better to separate because of the visible or the scroll range, the scroll value, if I crash the previous scroll value. And because then I'm gonna have to change what nodes I traverse first. And so on the presenter, I have to listen to this. Now I have to create a function on the view. It's gonna be the same. I'm gonna try to do it from the model first to see if it works. So the other thing is to create the hash map. I think that this class also has this is the part that I was talking about before, where in order to not check each time if the node is a root, I think I have to check to see if it exists, if the parent path exists on the hash. If it doesn't, then it's an error. So I should continue. Path should be probably the first thing. Yeah, but I have to. So the question is whether or not to. Where should I create the root, the first node, which is the root path? So they create this on the update tree, I think. And then they call it create tree to call recursively. I'm just gonna pass whatever it needs to create. I'm gonna copy from this function. Basically, the create item from the tree is the thing that creates the item as the sense, and then whatever we pass here is gonna be the parents of the current node, and that's how it builds the tree. So it calls recursively. The tree is the class that initializes on the constructor of this class here. But then I think the first time that it calls this is the create item is gonna be from the update tree, which is the roots. So this it doesn't pass any path. So maybe I should probably do this outside of that function. But then how do I make sure? I think one option is to check to see if the tree has a first child on the batch. Not sure if it's very good because then you have to check each time that the function is called, so it's probably better to do it outside. Then the problem with doing outside is that you run the risk of calling the function without the thing. So obviously, yeah, but if I have to put the error message, then it might be better to just check one time. I'm gonna try to just create, but if none of them have a tree, hmm. So I think I should create this in the constructor probably. As I build a tree, I create this. And then I make as a member variable. Since they are not doing a path there. So I assume that they're probably gonna put the information on the function. So they send the function as the first arguments. Oh, so the first node doesn't have anything. So I'm gonna create that on the constructor. But I think, and then I'm gonna make it as a member variable. So then I put so you just check to see. So I'm gonna put an empty string, I think. So I put the nodes, the root node on the hash. And the problem with this is that is like any node that doesn't exist on the hash is going to put as a child of the roots. I'm thinking about mapping the roots with an empty string. I guess I can. It doesn't matter that much. I'm gonna think about this later. So I'm gonna put as a string roots on the hash in the beginning. Then I check here. Problem is that's gonna add in the wrong thing. It's just gonna add an extra level because I'm putting the root node on the batch. So like this is what I was thinking. The order is gonna matter because if it doesn't, but I think on the first batch, no. But if I put the root first, it's gonna put the root on the same level as the other ones. So I do think that I need to put the node. I need to create another function, and then I need to add the root node first. So when I create the tree, I should probably create the item with the root path. And I should put on a function because I'm not setting the root nodes on the constructor, I think. I'm setting based on a function. But this is a model. Yeah, I think on the view I was doing based on the model class. So I was getting from the model. But it's not gonna be on the constructor. And so I'm gonna have to change so that I add the roots on the. So I should probably change the logic on the model as well. The root node should be. I should use the same path, but instead of calling the load data from the. I have to call from the path. I just need to skip the first. But maybe it's already what's happening. I'll think about this later. So I'm just gonna see what do I need here. I think I can do like this basically because I'm doing breadth first search. So the nodes are gonna be, but it might mess up. But I think I can like because this is a kind of like a reflection of the model. Like the way I build the model and I push the nodes through the queue ensures that the nodes are always gonna have the parent inside of the batch. So I basically just need to guarantee that the order in which I get the nodes from the queue is like respecting the first in first out thing. Because then it's gonna. Yeah. This is kind of annoying. So I guess I'm just gonna copy this all this stuff. And then I'm just gonna replace instead of subdirectory items gonna be current tree node. That's probably the easiest way. The biggest difference is gonna be on the file which they create later, and then they have some other functionality just for the search here. But if I do, I'm probably gonna implement search, but I'm gonna implement later, and I'm gonna do it on another component. So I'm just gonna communicate this one probably through signals or something like that. Or on the other one, I use directly the dir access, so don't need to call this one. But I would have to create. So it's either going to be an extension of this class or another class that is based on the same principles. So I just have to update the tree based on the search state. Let me copy this stuff. I just realized I might need to create this thing because I think that they use this file list here. And they push this. So they sort the files here. And the sorting, I'm gonna see if I need, I do before the batch. So I just create another function that receives the vector. I just realized I might have to do a queue because of that. Because I think the sorting works on the queue. Maybe not, because this no, this is list. So I'm not sure if this is necessary or not. Sure, maybe not. Because they have another class, and I think that they use the other class for some stuff related to files. But I'm not really sure how it works. So I think this is just gonna be the path that I have there. So file metadata is the path. This will be the name. Icon size. Oh, this one they had based on the configurations, and I got the actual value by going over the class. But maybe later it's better to change. This might be, I think this is the difference. Because here is doing based on the parents. So this should be the parents. And it's gonna be, so here, sure. Hmm. Yeah, for the roots, I'm gonna have to think about. I'm gonna just do the like this. Russ was for. So some of these I'm going to check to see based on the is directory thing, which is kind of confusing. I think sats metadata is there. Sat text is the same. The same. And this is different. So this one I'm think it's gonna be similar, so I'm just gonna remove this. I'm gonna have to see if I move to the not sure if he's gonna complain. He did complain, so I'm just gonna put public and like wrap the thing on public and then put private again. There was a situation, I think one time that I ran this and it was kind of weird because I pressed Control C and then later on it uh, showed the rest of the messages. So I'm not really sure if it's something that's happened before because I didn't went over with the debugger to see like if there's an issue with this. So it looks there must be an issue, so I think I should go with the. Because usually when it doesn't display 3 messages after the last one that it showed there last time, there is because there was a problem with memory somewhere. So I have to see if this is the case. It probably is. Don't solve that. Then after I solve and I run, I'm going to open from the editor and then see if is loading the directory. And if it does work, then I just have to implement the reaction to the events, I think, after. So not really sure which one I should implement first, the cache or the reaction to the events. I think that should be the cache probably. The reaction is going to depend on the cache. So I think should probably try to implement the cache, the LRU cache on the model first. Then implement or try to implement the reaction to events. Then after I do the reaction to the events, then the last thing to try to do is to change the configuration. So I have to move the configuration to the I'm gonna have to change also the logic of what happens when you select the options on the GUI to add a file or something like that. So that's stuff, but I think I'm gonna do that later. I was looking into all the parts that the file system, the way that it was used before, is working. It is the main thing for which is used for is just to get the root directory. So I think I can change for getting from the tree class instead. So it should be easy to refactor. So I think the thing that's gonna take a lot more work is the changing the functionality of what happens when you select an option and moving the configuration to the file system presenter. So I need to move the cache of the configuration of the file system presenter and then change the model to. I'm probably gonna have to either create another function or change the function that I just created to do it differently in case you have a previous configuration. I think on the uncollapsed maps it's not that hard. I just call recursively if there are uncollapsed maps. So I could probably have a call function first to transform the uncollapsed maps into a hash map or something like that. Then I set that on the model and then I check on the screen on the load data on the model. I check to see if the current directory is uncollapsed and then I load that data first. So I recurse that. But the tricky part is the scroll. So if you start everything from a previous scroll position, then the traversal of the tree is kind of annoying to do. I have to go from the place that is showing to the root, reconstruct the uncollapsed paths the minimum way possible, then build the visible parts first up until a buffer size, which has to be based on a calculation of the viewports. So calculate the viewport, calculate buffer size on top of the viewports, traverse. And maybe actually it's not that hard because you can go from the root to that place. So I can traverse the uncollapsed paths and load each one until it gets to the roots and then just do the buffer after that. And then load the queue based on the visible range first, then go back and put everything on the cache, because I'm putting everything on cache, I can skip the computation after. So maybe it's not that hard. I am doing this. So I'm just gonna put this. Hmm. Let's have anything else. No pointer. Let's try this. So it's probably not closing the executable correctly. Yeah, still running. Maybe after I fix this, it's gonna fix. So still running the process before. When I run the debugger again, true. Let's see. Obviously, I assume it's the same, but it might be something else after. So it might be because of the threads. I'm not really sure. And this is weird actually. I'm gonna ask ChatGPT, see if it knows. Not sure if it makes sense to be the data from the model, because on the model I'm putting the guard there, the lock with the macro. So like the moment that the presenter gets access to the thing, it should be already safe to execute. But it might be because it's calling up the tree from different trans. Hmm. It's beautiful. Yeah, it should be after here. See if press of like this is not the original error, but it's still kind of weird. Also, it's saying that I can only set collapse on the from the main thread. So the easiest way to solve this is just comment the thing out, then I think about this later. But I think you can't call the function, the collapse function from another thread. So because I'm calling this from the threads on this kernel directory is complaining. I think that's what's happening. So obviously what I can do is just do it on another part. I can do it like loop over and then based on the cache on collapse. But it's gonna be kind of annoying, I think. I have to think about what is the best place to put or like create a function that loops over the or traverses the tree and then uncollapses everything. I can copy the get uncollapse path for the breadth first search and then mm. So maybe it's another function. And this is the last thing that I'm gonna try to see here because I've been here for a long time. I'm gonna stop streaming. So it is probably a problem with the like the data race. That's probably the issue. Mm. How is it going to? How is it calling that before it calls the gets batch? Oh, I guess that's probably the issue. Is that's like since the queue is being used, it didn't call the batch. So when I call the other function, it doesn't have the data, or maybe like something like this, or it got the batch but the data. I think it's something to do with the mutex and the thing there. So probably ChatGPT hallucinated the answer there. So I think in order to be able to use the mutex, I probably have to use the other threads to call the function. I think I can try to. I can see on the threads if it has. This is the same thing that is going to be dependent on the macros, so is the other implementation. And the problem is that wait to finish is not going to be good. I don't think there is a lock as well. Mm. I think I have to call lock on this one. This was something that I was thinking about before, and it's one of the reasons why I wanted to do the sorting later because like I think it gets more complicated to think about the function there if you are going to stop because like the idea that I have right now is like instead of doing like this, obviously I just do it based on the batch size. So I call the function on the thread based on the batch size instead of trying to traverse everything. But then the problem is that I have to remember the last part, the last path that it was. But maybe it's not that hard if I do it. And because the issue is that I don't understand the thing very well. Like, but I guess it's just gonna wait until like it's just gonna go until it doesn't have. This is another question actually. But I think when it is a file, it's not gonna push. And so it's just gonna go until it reaches the last level. So I think it doesn't matter that much. Yeah, I'm gonna stop streaming now because I'm streaming for a long time. But probably what I'm gonna try to do now is to instead of doing things this way, I'm gonna call the function from the threads. Like I'm gonna do the function based on the batches instead of trying to traverse everything. And then I'm gonna keep track of the last path that was. I'm gonna probably put a member variable in the class with the last path that was traversed on the batch. So I do the function based on the batch size instead of trying to traverse the whole thing. Maybe instead of emitting the signal, I return. This way, I'm not really sure if it's even better to do synchronously. I think it's probably better to do it with the thread. Yeah, so the only difference would be that I would call the thread on the function, and then I would wait for the function to finish, because it would be base. But then what's the difference? It does have a slight difference because the other, like, if you do it with the threads, then the main thread can continue to initialize everything. No, but if you, yeah, if I call wait to finish after, so I call from the scan, instead of initializing the thread on the scan, I initialize the thread to call that specific function, which is going to be this one, which is just loads one batch. Then I call wait to finish on outside. And then I think it's easier to just emit the event and do the same thing that I'm doing now. The problem with this other approach is that I have to call the function multiple different times, and then I have to think about when to call the function. This is slightly more annoying. Maybe it's better to figure out a way to do it like this, and then just solve this trans thing. Yeah, I think it's probably better to first try to make it work like this, because it's easier and also probably better than you just call the function once and then you just keep loading the directory and passing the information in batches through the queue and gradually updating the view. But maybe it is not possible because of the threads and the way that they designed the tree to work. So maybe that's the reason why they created the whole thing. But if it is not like that, I'm gonna have to find a way to change anyway, because there must be a way to incrementally load the tree. So like, I think that I have to, if they design everything so that the tree is created at once all the time, I think it's not very good. So I have to figure out how to change that. So I'm probably gonna have to change the tree class, because that's the only way to implement lazy loading. I think it's the only way to do it. So I have to figure out anyway. Yeah, I'm gonna think more about this upstream. So either I'm gonna continue like this and then just call the function once and update on the same batch size and gradually update the thing, or I call the function, I create the thread every time that I call the function, and the function executes until it completes the batch size, then waits for the thread to join, then it emits the signal after the function executes. Actually, I could do it on a loop as well. Just realize this. So I can initialize the thread on a loop each time and call the function and then wait to finish outside. Yeah, but then it doesn't matter. That's the problem. It only makes sense to wait to finish if you put on the notification process. Otherwise, it makes more sense to call the function right away. So I think trying to do like this is probably better. Then after this, create a cache, check for the cache here, or adds each item into the cache as I update the queue. Then from the view, react to events based on the cache. If there isn't anything on the cache, you update from outside and also use a mutex to stop. databases and then update the cache externally based on the view. I think for the view is probably better. I think that's how they do it on VS Code as well. Depending on which path they uncollapse, you traverse that path a little bit, like to a certain depth, depending on the size. So yeah, but I think it's probably worth it to think about this later. So I'm gonna try to fix this first. I'm going to continue to try to execute this plan here, these steps, and the design that I talked about here until I make it work. So if I can't for whatever reason make it work like this, I'm gonna think about a different way to do it. But probably next time in a stream, I'm gonna continue to try to implement this. So see you then.